Hi everyone. So welcome to this course. It's IDS 594, ML deployment or MLOps. So my name is Teja, and so the way we're going to work with the videos is, you all by default are muted, but if you have questions, you can unmute yourself um, and ask questions, or more efficiently, you can also use the chat function and but and reply to everybody, and that way I can look at the questions. So with that, let me start sharing my screen. Okay, so this is actually, so the screen you're seeing is actually a fresh installation of Linux OS. So I wanted to start here because today we'll actually be doing a little bit of setup. Um, Yeah, so if somebody is not seeing the screen, then please comment on the chat. If not, I'll assume that everybody's watching it. Okay. Okay, so welcome to the course. I think some students are still joining, but let's get started. So this is a course where, I hope, so where we're going to look at how to deploy machine learning models in various business settings and mostly in production settings. Um, so firstly, some logistics, some logistics about the email. So I sent an email to students who are registered in this course, which had a few pointers. First thing was the link on, if you go to Blackboard as well, you'll see a link to the course webpage, which is this, okay, which is being shown currently. The second thing is you must have got an invitation to Slack. If you have not joined, I strongly urge you to join because it's a great way to um, um, communicate with each other as well as with the teaching staff. The third thing is a OneNote class notebook. That's actually really optional. If I scribble something down during the lectures, I've shared a class notebook where you can get the my writings. Okay, and you can also, so there's more functionality there. We'll explore it as we go along, where you can also write something and we can discuss. I can see it and we can discuss. So those are the three links um, that I wanted to first start with. So let me then get into the course logistics. It's on the web page at the top left. So this is actually only a 2 credit course. It's on Thursdays and at 6:30. So the model is going to be online synchronous. It will be delivered over Zoom. So you also have the Zoom link with you. Most importantly, the Zoom session is being recorded. If somebody does not want to be recorded, then try to use the chat. But this was the feedback I got from the previous lecture on a different course, that I should probably record the session. So there's a teaching assistant for this course, Teng Teng. She may be online right now. Most of the communication will be on Slack, which is basically, because this course is being done online, we want to experiment with this more medium for faster turnaround and more interactions between the students and with the teaching staff. Now, office hours also, we can schedule it via Slack, as well as we can have Zoom meetings and so on. So there is actually a textbook for this course. It's mostly it's optional in the sense that you don't really need to uh, buy it. But if you buy it, it's here's the link. It's a $5 ebook or PDF. And a sample is provided if you don't want to make a decision now. So that textbook is mostly just to structure our content So this particular topic or the set of topics that we'll be looking at, there's actually a lot of new things coming out every day, and so it's not it's not a well-found field of study by itself. Now, with respect to software, today I'm going to demonstrate a little bit of software in real time. Let's see how well that goes. But there is going to be different various softwares that we'll be trying out. Actually, we'll be probably trying out a few things on one of the cloud providers. So we'll see that later, not in this lecture. But there are some softwares we'll see. Today we'll look at Python and Jupyter and so on. Hardware. Um, we don't really need any hard computing resources at the moment, as in any beefy computing resources. But it's good to have, like if you're on Windows, because most servers run on Linux, and a lot of deployments, like machine learning models and so on, happen in Linux-based servers. It's good to either use a virtual machine with Linux installed. You can also use Mac OS natively. Um, but there is a Windows virtual machine available at desktop.uic.edu. Okay, so with that, let me get to what's the. I mean, I'm going to talk about the objectives of the course pretty soon, but before that, just the logistics in terms of how are you going to grade. This is a two-credit course, so about 8 lectures, eight sessions. So most of the assessment will be via a project. And so what does this project entail? So the project is going to be basically, apply or take something, one of the lecture contents or the topics, and build on top of it. And you'll see an example today when I'll show you a simple deployment of a machine learning model. So that's, it's an 8-week effort, and you have to submit your project report. There'll be some additional details that I'll give pretty soon in the next week or so. And the grade will be entirely based on the project, 80%, and participation basically on Slack or here with questions, on the chat and so on. That will be 20%. So, and one more logistical detail is, since this semester many classes are online, you already must have been seeing this with some of the other courses. So we will be doing, since this is a synchronous online mode class at the moment, you would need a few resources. And the most basic resource is definitely an internet connection to participate in this session. So I mean, beyond that, if you have a decent resources like webcam, mic, and things, then it's even better. Okay, so and if you don't have it, then ACCC has some resources that you can try out, and here's some links on this page. Okay, so with that, let me come back to uh, the what is this course about, because it seems quite broad: operationalizing machine learning or ML deployment. Um, so the course is about basically it's actually an introduction to ML deployment. We are not software engineers. This course is not for software engineers. So it's actually an introduction or a brief survey of some techniques to deploy machine learning models in production. It basically complements the things that you've seen in 572. Some of you have done IDS 572 or 575 or even 576, where the focus is on building a really good model for whatever objectives, accuracy, precision, recall, whatever it is. But here we want to take a model and try to put it in a system where we can we can serve many prediction requests, for example, or if you want to compare two different models in some sort of A/B testing, we can do that, and so on. And there are many models that you will develop typically, and so how do you catalog them, how do you work with them, and so on. Okay, so that's the general idea behind this course. Um, there will be some auxiliary software engineering ideas that I'll try to bring up. For example, version control. I know some of you already know this from other courses, but Git or Subversion or any of these version control systems, it's good to know them. And we'll look at containerization using Docker as an example in this course later on, and also some other topics like continuous integration and deployment ideas. So that's generally a tentative list of topics. But to keep it structured, as I said, there's that textbook that was recently released, a few months at the beginning of this year. Uh, so we'll kind of follow the structure of the textbook. Okay, so today we'll look at, so I haven't filled out all the topics yet, but today we'll be looking at serving machine learning models using simple web service. Okay, and in particular, we'll just look at a Flask-based web server. So any questions at this point about the course logistics, the topics that we'll be covering? Um, the outcome of this course is for you to not be an expert in deploying machine learning models, but to know that these are the tools, the ecosystem that's available, um, and so that you're familiar with it when you get into a professional line of work. Now, there's a question about, is the project to be done individually or in a group? It's actually a group project. In fact, um, I don't know if it's mentioned here yet. If not, I will. So there's going to be a project details instruction document that will be added to the course logistics page. There will be something that will be released here, and there will be a link here. It is a group project. You self-form the groups, but there is no immediate urgency because there's no assignments and stuff tied with this here. The group size is depends. So we have, I think, 60 plus students. So the group size, I think, is probably 4 or 5. The lower bound is 4, but 5 would be ideal. Yeah, but the details will be in a document that'll release pretty soon. Okay. Is there any other question? Um, is there any particular expectation that you guys have? You can either post it here or on the Slack. So the Slack is really to share, uh, you know, information about this nascent field. It's nascent, but a lot of software engineers are building a lot of complex software to deal with machine learning life cycle in some sense. And so there's a lot of new things coming out every day. So try to use Slack to share information with each other. Okay, so if not, let's so so today we're gonna look at basically chapter 1 and 2 of this book, Data Science in Production. And so today's lecture probably will be pretty light. I'm not expecting, so in terms of background, we're not expecting um, so we are going to be moving it's going to be complementary to the machine learning model development itself. So you don't really need to know the details of building models and how do you benchmark them and so on, like the training part. But we'll be looking at how to take that model and serve it basically. So let me start with and a few things. First thing is, most of the course is predominantly about Python and Python related ecosystem for ML deployment. And okay, there's a question. Okay, so let me finish my thought and then I'll come back here. So mostly we'll be looking at Python ecosystem, and that makes sense because most of the offline work, most of the things that you study in classes as well as the in data science teams in the industry, most folks who do, maybe not engineering, data engineering, but data sciencey stuff, business analysts and so on, they predominantly use R or Python and Python. And once these ML models with batch data typically are mature enough, they tend to, if they're in Python, they tend to move seamlessly into production, either for internal consumption in the organization or into a product. It's a little bit easier within the Python ecosystem because Python is not just for statistical analysis, but also it's a general purpose language. So that's what's observed, and Python has few advantages. I mean, many languages have those advantages as well these days. But for example, using databases, access to databases, or access to many multiple sources of data. For example, Google's BigQuery, SQLite through MySQL, or like you can also access S3 using Amazon's libraries and so on. And and especially these days, if you look at a lot of companies, they do collect a lot of data. Generally it's in terabytes, sometimes even in petabytes, and this data is mostly these days, this data work is being done using Spark. If there is any uh, jobs that need to be done on this type of data, any analytics that needs to be done on this type of data. Where the big key central idea here is that you cannot dump the data onto a single machine disk. So you really need to do distributed processing of this data. So you really can't load the data into memory or just work with this data set on a single disk. Okay, so you want to use Spark type of technology, and that also has great bindings with Python. So that way, it makes sense to like PySpark is the module, which has actually, I think, it's not fully feature compatible probably, but has good compatibility with like if you know Pandas data frame. Um, and as you know, most deep learning models these days are built in the Python ecosystem, both on the research as well as, if you go to TensorFlow or PyTorch's websites, it's also mostly it has good Python APIs and many interesting libraries. So what's the objective throughout the course is basically to learn patterns and not the specific tools. So there will be some choices. For example, today we'll look at, I think I'll try to use a virtual machine from some vendor, but you don't have to get the virtual machine from that vendor. You can actually get it from, for example, AWS, but I'm going to skip AWS today. Um, so in that sense, we are going to just look at patterns, choices that we can make, and not the specific vendors. Um, in terms of deployment targets, so where all do you deploy machine learning models on local machines? You don't really deploy. So you want to deploy a machine learning model when you want it to be consumed and interface with other things, other people, other programs, right? So you can deploy ML, machine learning models on local machines, like on premises. You can have self-hosted clusters, for example, but you need DevOps skills, which just means that you need to know how to deal with backups and security and identity management, access management, and so on. And many of these things are abstracted away, not really abstracted away, but kind of made easier using many cloud offerings, like some of the names that you might have heard of. uh, Heroku is a platform as a service. It manages a lot more things and abstracts many things away from you. So you just have to work at the level of a Python script, for example. um, and then of course there's infrastructure service providers who also have overlaps with platform as a service type of offerings. But Azure, GCP, and AWS are the big three. Um, so in fact, I think in this course we'll try to focus more on the managed cloud services. Um, and the decision to go with one versus the other is really depends on what is the business need, whether it's in internal consumption, external consumption, whether it's a proof of concept, or whether it's actually a new something on top of an existing data science workflow pipeline, as well as a product that you already have. Okay, so that depends on your skills, um, what scale, reliability, and security that you want. For example, there are a lot of apps these days for which machine learning is a central aspect. For example, Google Translate is literally is a sequence type of model. Not just that, but maybe something very complicated there. But so for those types of apps or services, this is a central piece, right? But for internal consumption, where you're reporting a histogram or alerting system, where if the sales dipped by 20% from last week, then you need to alert somebody. Maybe you don't need that scale. It depends. Okay, but there are two things. One is two things I want to point out. Local deployments are generally hard because you need to know, and generally these deployments are on Linux type of OSs. So you need to know Linux security. You need to know how to, as I previously mentioned, you need to know how to give access to employees, different types of employees, maybe somebody in the finance team, somebody in the marketing team, somebody in the product team itself. Backups as well as hot switching. So you cannot turn off and replace a model by just deleting a file from somewhere and then uploading another file, right? I mean, there's a time that you will consume while doing so. But cloud deployments are also, not easy at the same time, because these days, at least, the amount of offerings and managed solutions that are being provided, like if you just go to AWS's website, EC2 instance, which is just running, starting single instance, single compute resource, is just one of maybe 60 or 100 different icons that you'll see. So you need to know the ecosystem, and there are already people who specialize and get certified on various aspects here, like cost management or various things, AWS management uh, activities. And there's also vendor lock-in. For successful business, it doesn't really matter. Okay, this is not an issue. So anyway, let's go to software tools. Python. Some of you have used Python before, or maybe all of you. We look at, you can use, you know, any text editor. Sublime Text is one example. You can use IDEs, PyCharm, VS Code. So I'm just throwing out these names because you can literally download them and use the trial versions. In fact, um, uh, PyCharm has a community edition. VS Code also has is basically community edition, I think. And Sublime Text has a, you can evaluate forever. So you can try this out. In Jupyter, so the third point is Jupyter. So these text editors and IDEs are great. There's also Jupyter notebooks, where you can do scripting and a lot of visualization inline, and have markdown comments and so on. You can also have variants like Google Colab, and some of you might have seen Databricks. It's a vendor which gives offerings on top of Spark. So these variants actually allow you to collaborate between the data science folks. So if you're doing, let's say, modeling, and somebody else is doing ETL, or just data preprocessing, then both can look at the same notebook. Okay, and so there's a sharing aspect that's also available. So those are my comments about Python, and what we are thinking in terms of this course. So before I get into these parts, which are actually more, I'll try to do it. It's going to be like a lab where I'll try to set up things. But before that, let me answer one question, which is about a real-time A/B testing experiment. I'm hoping that that's the case. So if you look at the schedule, this online experimentation is the last lecture. We'll try to see. So you can actually use Optimizely. You can create a fig on Optimizely. I think it has some restricted features that you can try. So I'll try to see if I can set up a something there. But yeah, so we will try to set up an A/B testing experiment if possible. I mean, we can actually set it up ourselves. We don't really need to use a third-party vendor. For example, like even this website, for some folks I can show this particular website, and for some folks I can show some other website, right? It just depends on if I can have a router which routes to different uh, websites. In fact, you'll see today, for example, we'll be setting up a Flask server. So the Flask server will get, so the Flask server will have a way to get to, you can query, for a prediction. So you send an image to the Flask server, and it'll say, okay, this image have a dog or cat. For that, on the Flask side, a very simple way to do A/B testing is to, pick a random number, numpy.random or something, random. And depending on that, you serve the response of model 1 or model 2, and then you can really do A/B testing between the two models in terms of whether they were liked, because once you send back the response, maybe the person will actually give you the true class, and then what the performance of the two models is in the wild, for example. So we'll see. Is that fine, Big Pachi?
Yes.
Okay.
Yes,
Okay, so what we're going to do now, so tell me if I'm slow, but so we'll set up Jupyter Access on Vultr. So I just chose Vultr, but it doesn't matter. So it's a VPS provider. So you just get a shared virtual machine instance. So other services are DigitalOcean, AWS EC2, Google Cloud. There are other alternatives, but let's do that. So what we are trying to do is, so in the first hour or the first part, we're trying to just get a few things. First is set up a few things, and by setting this up, you'll see that there is a lot of DevOps work needed, and some of it is also needed if you use AWS EC2 instances, for example. But we'll set up a few things so that we can access Jupyter, and then we'll also uh, sorry, there was part 2 and part 3. And the second part of this beginner section is to just get a basic PyTorch model that we can dump to disk. Okay, and so that's part 2 and 4 basically. So I may deviate from the examples in the book. The book is gonna, I think, uses AWS as an example to set up Jupyter, but it's not that different. Okay, so okay, I don't know this. Okay, so let me log in. So if you have any questions, you can use the mic to chat with me. I mean, ask. So I actually have two-factor authentication here, so let's deal with that. Okay, so let's deploy an instance. So this is just for some of you to. So I'm okay. Great question. There are some questions here. So what is Vultr? So it's just a service provider which allows you to rent compute. Compute just means a machine like a computer. Okay, it's going to be a virtual machine. So for all intensive purposes, it's basically a computer. I will pick a Linux-based computer, and it's going to. I mean, typically we'll interact with it only through command line. Okay, and that's a basic unit. Even on AWS was got famous with EC2. EC2 is just very similar to Vultr. Okay, Vultr is just a vendor. You can use other vendors, as I have mentioned in the um, uh, mentioned in the notes in the lecture webpage. Now, do we have to pay for it? For Vultr, you have to pay, but don't worry about the specific vendor. It's not that important. For AWS EC2, you have free tier instances, which are small, so you can actually work with that. Today, I just wanted to show a different vendor, and next week we'll have to do something with AWS anyway. So maybe I can comment that part out next. Point that out next week. So what do we need actually? So compute, and it doesn't matter Atlanta or not. Server type, let's choose something, or maybe Ubuntu. And so there are a lot of prices, but let's get something. Okay, let's use this. And startup script and all that. I may have some. Okay, let me add an SSH key. I don't know. Here. Okay, so actually that's a good point. So what is this? So my current machine is Linux Mint, right? So let me actually show you guys how to. So SSH key is very important, and I was going to talk about it soon. So SSH key and the secret, they come in a pair, and they're useful for passwordless access to things. SSH just means secure shell. So So let's actually create a. So I'll just generate a key. You can give all this information, but I'm just gonna default. So what happened is it just created a couple of files. Okay, the .pub means .public. It's a public file. So that's the file that you share with other parties. In this case, I'm going to share it with that server. Okay, I don't need any first name and label. Okay, so I'm just starting a machine. Now, in the meantime, let's see. So there are a few things, but we'll focus on getting to Jupyter. So actually, I think I may have, yeah. So we'll try to enable only SSH only access firstly, um, which means that we can, so we can do SSH user at some IP address, okay? And we'll be able to SSH into the machine without using a password. So we'll get there. Before that, I want you to, if you open the course page, there's this under software tools for deployment, there's a part which says setting up Python. Some of you have already done this, so this is not new, but for some of you it may be useful. So let's see if the machine is installing. So I have an IP address here. So I don't know if it works. I'll have to check. Um, I don't know, did it start? No idea. Okay, let's try. Could not resolve host name. Okay, that is because of the space. Okay, let's say yes. Oh, it's asking for a root password. Okay. So let's see. So let me stop the share for a second. Okay. So if some of you want to follow along, you can also try it. Like you can start with a virtual machine, a virtual box, and then install a virtual machine there. So I logged into the machine. So you can see that it says root at that machine. So like you can get the IP address by typing IP-A, and that's the IP address. Okay, that's good. So let's go to. So what are they supposed to do? Okay, firewall. Okay, first I'll restrict the access. Um, actually, okay, let me just use that. Add a user called Teja.
Professor?
Yeah.
Will you be sharing all the commands in some text document or something later on, because we are not able to right now follow up?
Yeah. So there are some commands. So this part I did not add because it's specific to this particular service. But yeah, I will write it. I'll write it. I mean, this is getting recorded, but I'll also write it. So for example, you can see setting up Python is there, but the part before that is not there, right?
Yeah.
Right. So the part before that is what I'm doing now, but I will add it.
But are we supposed to pay for this? Because now if I try to access from the products, I don't see the cloud instance which you were actually choosing.
So for this, you should not use vulture. So this you will not be able to follow because you need to have an account and you will have to pay. Okay.
Okay.
But this one is not important. So this particular vendor is not important. If you have an AWS account, you can start. If you don't have an AWS account, that's even better. Sign up for AWS. You can start the same type of instance for free. Okay, no, you don't have to pay anything.
Okay. Okay. Then we'll check that out.
Yeah, so I just wanted to show a different vendor for today. Tomorrow, I'm sorry, next session onwards, we're going to use AWS anyway. I'll point that out.
Okay.
Okay.
Okay. Thank you.
If you really want to follow this part, you can actually run a virtual machine on your computer. For that, you'll have to use a software called VirtualBox or a VMware Fusion or something like that. Okay,
Okay. Okay.
and get a Linux instance.
Thank you, Prof.
I had a bad password. Okay. Uh, okay, I'm just creating a non-root account. That's all. Um, okay, so this is a non-root account. So let me add. So how do we create an SSH base login? We'll do the following, which is firstly is is SSH running? Uh, I don't know if this user was in the sudo group. Okay, okay, that's not good. Uh, so I forgot to add this user into like in a sudo group. So I'll just add. Okay, that's fine. So yeah, I just wanted to check if SSH server is running. Okay, it does. They do have a server. Okay, so that's good. So in my account, what I'm going to do is copy the public key that I had. So um, I already copied it once, but uh, let me open another terminal. So this public key, I want to paste it here. So it has to be in a certain directory. Um, so I'm creating an SSH directory, and I'm creating a file where I'll paste that public key. So that way, when I try to connect, the machine will know based on this key being in the in its registry in this file, for example. Okay, so the left-hand side is my local computer, this Ubuntu machine, local machine, okay, T-Acer or whatever it's called, and this right-hand side terminal is on this virtual machine that I just started. Okay, so anyway, all I did was copy a key from here to there. Um, so wasn't there? Okay, oh, not fine. IP address 45 dot. Okay, so see, I did not type any password, but I'm on the other machine. So the other machine you can identify by just looking at the stage at the other machine's name. Whereas here you can see that it's IDS user at my local computer. Okay, so all I did was generate a key in the past 5 minutes. Generate a key. Okay, that key got generated in this particular folder. Okay, it's very similar in other Linux systems, not just this particular Linux machine. So this is the public key. I just somehow copied that key's content into a specific file called authorized keys. Um, and that way I don't have to type passwords. Okay, so that's SSH access, and I can disable password-based access. So that restricts other people from trying out passwords in a brute force manner and logging into my machine. I mean, I'm pretty sure by this time maybe somebody has already logged into this machine, but it's okay. So that's that. So any questions at this point? So there are a few things you can do on that in this machine. For example, you can do. Oh, sorry, this is my local machine. Um, Something called a firewall. Okay, so that firewall can. So UFW is an example of a firewall. So let me install it anyway. What I added myself into sort of this, right? Um, okay, let's see. Okay, anyway, apt install. Okay, think, okay. So if you look at, so this is a firewall, just like firewalls you find on Windows and Mac. It's just saying allow SSH and nothing else. Okay, so that at least is an example of Linux security. Okay, I'm trying to give some examples. Um, so some example of basic security using firewall, using a simple firewall called UFW for Ubuntu or Debian based systems. SSH only access. I didn't disable. I can show that, but I think I want to move on. So you can actually change the, this is, the local machine, and this is the machine. So you can change who can, how people can access. For example, you can disable authentication using password. Where does it say that? Yeah. So password authentication is yes, I can disable it. So that's an example of security. Okay. I just want to give an examples today. So because this is not our objective. So let's now focus on the actual Python installation. So let's go to setting up Python. So there are many ways you can install Python on a server, like on your server, but I would suggest use Anaconda Python. So this is, I think, um, is a really cool, really good tool for the for setting up Python-based projects. So in particular, so so some of you might have seen the command called pip. Okay, with pip you can install different packages. So for example, you want to install NumPy, if you want to install pandas, you can use pip install the package name, and you can install it. So Conda is very similar. So it's by the folks who make available this particular software called Miniconda. So It's very similar. It's a package manager, but it's also what is called an environment manager. So it does two things. One is install packages for you, but it also manages environments, and that's what I want to get to today. Okay, so environments. What is the importance of environments? Is that you can have replication. So in an environment, the version of softwares and modules that you install, for example, within Python, let's say you're using Pandas version something 1.2, then so that's a particular environmental thing for your, let's say, development machine. Now, if you want to replicate that same settings in another machine on Windows or a production machine, then you want to use you want to fix the environment, freeze the environment in some sense, and that can be done in many ways. And Conda is one of the ways to do it. In Python itself, there's a way to do it called virtual VENV, which is available, I think, in Python 3. But that other package, the other function, command, is Python specific, whereas Conda is not specific to Python. So let's not worry about those details. For now, I'll install Python on that machine. Okay, not this one. This is my local machine. Uh, yeah, so this, let me just not fiddle with that. Um, so let me exit. Okay, so how do we install Conda? Let's just download. So although I'm doing this manually, there's actually ways to automate downloading the initial set of packages and installing them. But I'm just doing it manually just to show you how much effort you need to do to set up your machine. And you'll have to do this. For example, if you're consulting and the client will not let you download the data onto your local machine, then you have to set up something which makes sense, right? So. Um, Oh, I actually logged out, is it? Okay. Sorry, I was off the previous machine. Okay. Oh, that was faster. So now I'm going to just install Python. Just some terms of it, terms and conditions. Okay. So that's good. So once we install Python, you can also install pip if you want. So note that you actually have Python uh, in the Linux system. For example, let me. So let me SSH into that machine again. Okay, let's do that. So if you look at which -a, that's a Python. Okay. So there's already okay. Oh, it's not showing. Okay. I think I'll have to log in and log back. Okay, so the Python that I have is from this installation, which is in my user directory. So I'm not touching anything in the system. So I just wanted to see if the local system also had Python installation, but it doesn't look like it has, but it should. Okay, let's not worry about that. So we can install pip, but that's not very important. So next, the important thing to take away from this part is while installing Conda, we also want to install, sorry, we also want to start with an environment. Okay, so some name, data science development machine maybe. And if you have specific packages that you want to install, like pandas, um, pandas Jupyter, matplotlib, etc., you can do that at this point, but you can also do it later. Um, so you can see that you can set up an environment, and what is the use of the environment I just mentioned, that you have replicable, so you can actually save what you did on this environment. You can dump it to a file, and you can actually next time, file like environment.yaml or something, and next time on a different machine, like your colleague can also do the same, get the same environment. Okay, so let's see. So it'll install a lot of things. Um, Let me have a root account available as well. Okay, so what I'm doing is get an environment called data science dev, and so right now, if you see, the environment is a base environment. So you can actually look at Conda, I think, forget the command. Okay, sorry, I forget the command for um, listing the environments. Okay, let's see. This may not work. Okay, so currently we are in by default an environment called base environment. I'm going to deactivate it. That's how you deactivate it, and it's because I just created an environment called I provided a name called data science, and if you don't remember it, you can just go to Uniconda and you will see the name. It's called data science environment. Okay, and this environment doesn't have to be created here. It can be created in your project directory if you want. So anyway, activate develop machine. Okay, so what's the advantage of this is that now you have Jupyter, for example. So okay, so we got Conda installed and then the environment. Then what we do is Jupyter was already installed. PyTorch we can install later. What I want to show is next get Jupyter working. Okay, so before we start Jupyter, we can generate a config file. So let's do that. So what is the objective now? The next few minutes is to get Jupyter set up such that we can have a password-based access from our local machine. So from here, from my local machine, from this browser, I should be able to type that, for example, the IP address, or not, ideally I don't want to type the IP address, but I want to type local host something, it's a 9000, and be able to reach that Jupyter server, okay, which is over there, which I just started. So to do that, let me start by configuring Jupyter. Um, so what this command just does is creates a .jupyter, basically creates a folder called .jupyter and a Python file. But what's useful for us is actually we're going to set a password. So Jupyter notebook password, um, something 123. Okay, we set a password and it just is saved somewhere. Okay, so we set a password to Jupyter. Now what we need to do is start. Okay, we don't have to do a screen session, so I'll show you. Um, okay, so this is a command to start the Jupyter server. So let's do that. Um, but you can add a command which is called nohub, which lets the Jupyter server run even if you close, even if you log out from this instance, for example. So did not work. Okay, actually, let me not do nohub. Screen available. Oh yeah. Okay. So okay. So screen is a way to also do the same thing. So let me just do this. Um, I'm going to start the Jupyter server. Um, oh, okay. It's not installed because it says Jupyter is not installed because I'm in a different environment. So let me. Okay. So now it should work. So now the Jupyter server is running at localhost 8888. The no browser just says don't open the browser on this machine because we don't even have an interface for this machine, so we can't open it anyway. I mean, you can you can set up packages such that you can get an interface, but that's not our objective. So we got Jupyter running. Now all we have to do is somehow get to, to open, because we have access SSH access, we can go from we can create an SSH tunnel where the local host, that's a 9000, gets tunneled to localhost 8888 of that machine, the machine which is 4576, that machine that I just created, and I have to just give the right IP address there. So let me run this command. So this command has to be run on a local machine. Um, I don't have the terminal. Okay, so okay, I had opened 9000, and let's do what is the MAC address? 25, 6, 60, and 37. So that command should, basically don't do nothing. Essentially, it basically creates a tunnel. And now we can access a Jupyter notebook. Okay, what is the password? I think. So this is a Jupyter notebooks on that machine. So we took about, sure, we took 30 minutes, but we got a Jupyter notebook running on a machine. So you don't have to, so this is useful. For example, if you want to do deep learning, and you can rent a GPU enabled machine on AWS, and get Jupyter going, and use it, and then get your results or download the model and then terminate the machine. Okay. So anyway, we got Jupyter running. So yeah, so the next step. So let's step back for a moment. What did we do? We did a few commands, and I'm gonna give the commands as somebody commented after this class. I'll add it to this links that were there before. So next, what we want to get is get a basic model. So what I'm going to do this time is to use the code base that's available with the book, so as to not consume too much time. So instead of a PyTorch model, we'll use a scikit-learn model. Okay. So let me get the code base from the book. So uh, okay. Yeah, does anybody have questions in the meantime? So I'm going to download the code that is available with the book on this machine. Okay, I started the Jupyter notebook at the wrong place. So let me just go back to the main directory. Okay, so Git is something we'll briefly touch upon in this course. If you're not familiar, don't worry about it for now. But if you're familiar, all I'm doing is cloning a repository. Um, so okay, so this was that machine that I from Vultr, and I cloned a repository. So here. Uh, Oh, we'll actually need some software. But okay, so let's look at. So we are trying to get towards. So we got Jupyter running. So with Jupyter, what can we do? So we can do two things. One is uh, train the model, train a model, any type of model, scikit-learn model, or a deep learning model, or so we can train any model. We can also do a few things like um, not just data pre-processing steps, but you can also do interface with the web API. So, for example, in this cell, we're doing that. Um, let me see. Yeah. Um, yeah. So what I'm going to do is switch gears and talk about web service, because at the in this lecture we want to create a web server based ML deployment, and we'll create a model in between while doing this. So let me switch gears and talk about web services first, and then we'll get back to a simple model that we'll deploy. Okay. So I think it's a good time to take a break. So where are folks? Yeah. So I think somebody gave me the Conda command. Thank you. I didn't check that, but yeah, somebody asked if you can use AWS and stuff. Also, yeah, you can use anything. You can use DigitalOcean, AWS, anything. These are just names for people, firms which let you rent compute. AWS is not just compute; it is many other things. So we'll get to AWS next lecture onwards. Okay, but it's the same. It's replaceable. Instead of Vultr that I'm just showing today, you don't have to worry about Vultr. In fact, you can do whatever I did on a local machine if you want, local virtual machine if you want, just as a practice. Okay. So what we'll do now is take a break for uh, 10 minutes. So let's meet at meet again at 7:45, and I'll first take questions, and then we'll talk about deploying a ML model. Okay. Okay. Okay, so we'll start again. So at this point, I think I'll try to take some questions if there are people confused about what's going on. So just to give a lay of the land, what we did was, what we did for the second part of the first section, the first session, was to focus on starting a service, starting a virtual instance, virtual machine instance, securing it a little bit, um, setting up SSH based access, and then setting up Python using Conda, and then starting Jupyter. Jupyter also we set up a config which involved setting up a password, for example, and then running Jupyter server. Okay, once you run that on your local machine, you can tunnel through SSH, and so this is my local machine. Actually, I'm sharing it. Um, yeah, on my local machine, I could open like I can run Jupyter, and I can look at what's going on. So this is my local machine, and previously I had downloaded this to install Conda, right? So that's what we've done so far. So if you have any questions, um, other than the particular vendor that we're using today, that's just as an example. Let's see. Okay, so that's what we've done. Let's go back here. So we did all these steps. Conda installation steps are more clear because they're available on the software tools tab. Screen is just a way to run programs on a remote computer, and even if you log off, if a program is running, it will continue to run. For example, Jupyter Notebook, the command that I ran, even if it disconnects from that remote machine, as long as I don't turn off the machine, of course, the Jupyter server is going to continue to run, and so so I don't have to again log into the machine unless I have to restart the Jupyter Notebook, for example, Jupyter Notebook server, for example. So I can always tunnel, and there was the tunneling command that we saw um, here, something like this. So you can use some command like this, and I'm not explaining each and every part of this command, but we can get into the details maybe next time or offline on Slack. Um, but by tunneling like this, you can always connect to that machine. So if you keep that machine always on, which may be expensive if you're, let's say if that machine was actually not a, like a 1 gig RAM machine, but actually has a GPU, then it may cost you a lot more. So you want to turn it off. Okay, so that's what we did. So we're going to look at, so I was thinking I'll do this first to set up a PyTorch model and then do model persistence. But first we'll do part two, which is focus a little bit more on serving, and then come back to a model. So in essence, what we're going to do is spend the next 10-15 minutes on model serving and some details around that, and then generate a simple model, and I'll show you how which simple example model I'll work with, and then we'll serve that model over the internet, and all of you can actually access and access that as an API from your browser. Hopefully the same IP address will work, but we'll get there hopefully by in the next 30-40 minutes or so. Okay, so that will pretty much be the agenda or the roadmap for this lecture. So yeah, let me talk about model serving, and just a general introduction to it. Since the course objective or course title is machine learning deployments, we have to deploy models somewhere. So and deploy or serve models is all about is all about the goal of sharing results with others. Okay, so the models can be consumed by humans, for example, interactively on a browser or through an app, or other web services which take your predictions as input, or applications which take predictions as an input. For example, you may be predicting uh, uh, a bunch of recommended items to be shown inside, on an app which is an e-commerce app, right? So the apps will call your model, ask for recommendations, and then display those recommendations to the user in its interface, right? So the two ways there are two ways to serve models. One is the batch approach, which is what so people who uh, historically did not need a real-time did not have a real-time business need, they would do this, which is dump predictions to a database. So for example, at the end of every day, you have a bunch of new test instances for which you want to query the model, supply the test instance, get an output, dump that output to a database. Okay, so you keep reading something from a database, apply your model again and again, and then dump the results back to a database. Okay, and then from the database, as another application can read it and do something. For example, a client can read from the database and take some recommendations if needed. Okay, that's the batch approach. A real-time approach, which is what we are trying to get to here, so is where the client, or let's say a browser or the app, can directly query a model. So query a model in the sense that give it a feature vector and get in response a prediction. Okay, and so there's no intermediate dumping of results into a database here. And so you get the predictions back instantaneously, and the computation also happens, or the forward pass of this model happens instantaneously. Okay, that's what we will try to do today. And how do you consume from prediction services or from any such web service? So consuming information like prediction outputs or anything from a web service requires using web requests, and so you can read the response that you're getting from a web service as, for example, it could be a JSON response, or you can feed an input. You can make a request to a web service using a JSON payload. JSON just means like a certain formatted XML or a certain formatted field, and you'll see that it just looks like a dictionary, Python dictionary. Okay, so actually, at this point, I think we can go to this example here in cell 1. This is from that repo that I just downloaded, and I can link it. I think it's linked. If not, I will link it on the page. For folks right now, maybe I can just share it. So that's the repository that I cloned earlier. There's the, sorry, that was not there. Yeah. So this is the command that I ran, git clone something, and it downloaded that folder. Okay, it's a Git repo. You can go into it, and to figure out whether it's a repo or not, you can look at hidden files, and generally you'll have a. Okay, I don't see. Oh yeah, it'll have a .git file. Sorry, .git folder, which will contain which means that probably this is most likely a Git repo. And we're going to talk about version control later, okay, in a couple of sessions. Anyway, that's how I got this file. Since that file was in that folder, I could, in the folder which Jupyter is accessible to the Jupyter server, I started that particular notebook. Okay, and it's all running. So this browser is on my end, but the Jupyter server is running on the machine which is at this IP address. So let's look at the cell. So this cell is using the request module and is making a GET request. So GET request to a particular web service. So behind this URL is a service, a program that's continuously running and is accepting such requests. For example, I think there's a GET request. So /random is asking is telling the service to return a random fact about cats, I think. So when you do a query, so this is a query to this particular URL, you get a result, which is the response object. Second, something happened. Okay. And then you can print the result itself. That response object is essentially, if you print the result, it'll just say response to 100. But if you look at the JSON field in it, it has many fields. What was the source? Because the response from this service is providing a lot of information. what we care about is the text field, which has the actual fact about think cats. Yeah. So actually, if you want to try it out, you can also do result is equal to response dot get. So this is a very primitive way of doing these queries. Maybe it did not work. Okay. Okay. Request. Oh, I did not run this at all. Oh, wow. Sorry, this is a new machine, so I did not install uh, uh, request module. So let's go here. Conda install request. So in this instance, it's install is acting. So Conda is acting like a package manager. Previously, when I created the environment, it was acting like an environment manager. Okay, so that's good. Now let's restart the kernel. Okay, wow, request not found. Let me just check this. Oh, that's a good point. That's a great point. So actually, this was on the base uh, environment. I don't know why I'm going to base environment all the time. Okay, let me just. Actually, somebody else also posted what environments. If you want to know what environments you have, um, somebody posted that this is the. Um, Omjit posted that these are the two environments. So there's obviously a default environment, which is the base environment. Uh, and every time I log in, I think it's set up such that it will always go to the base environment. And data science dev environment is where Jupyter is, and that's where when I did these kernels are from that environment. Okay, so I need to switch to this environment. Um, okay, okay. So there are more advanced packages just as a pointer. For example, I don't know if people have heard of, for example, a little bit older package called Beautiful Soup. Uh, is the name of the package that also can helps us parse. It's these things are useful for scraping, web scraping. Um, okay, so now okay. Making a second request. What happened? Okay, that's fine. Okay, I think. Uh, isn't it JSON? So I'll have to see. Oh, the response is actually an HTML response. So I'll have to see if the same command works. I think it's not a. There's some error with the response from our website. I think, but request was fine. Okay. Anyway, some. Let me change it to, for example, my website. Maybe it's the same error. Yeah, okay. I think when HTML, so this is not really a web service because it's just returning the HTML document with all the things. So I think here you just need to use a different, you see, uh, headers, maybe raw or text, maybe directly. Yeah, so the whole web page is down, is in the response. Okay, doesn't matter. So this is a proper web service because it's actually giving us a JSON response where what we care about is a random cat fact, and in this case we got the random cat fact, which is this. Okay, so that's a one way to query web services, but there are many other. There's actually some a tool which maybe I'll show it later called Postman. You can use Postman to also query. You can also use a tool called curl. Maybe it's not installed, but yeah, it is installed. So you can use curl to also make queries to a web service. Okay. But here it's programmatic because we can use the results and process it and do further processing. Uh, you can also use curl later. This code, so you can just get this code from the GitHub link I presented. So this is the link. But I'll add this onto the notes page for the lecture one notes page. So that's how you would make a query. Now let's go back to. I just wanted to show how the query looks like. So yeah. So I just wanted to. So how do you consume? First, you make a request and you get a response and you process a response. Now, how do you output predictions? It depends on what type of server you want. So we will see, and we'll see today, we're gonna have a service which responds to both get and post requests. I think, although we'll just handle get requests, I think. Um, Okay, I'll double check. But we can respond to different types of web requests. The typical ones you will respond to are get and post. Post is for more elaborate query, like when there's a payload, like a whole image. Get request is where, for example, you can have string arguments like question mark. Um, you know, so get request. Here, this was the example of a get request where there was nothing complicated going on. Uh, sorry. uh, just asking /random is the endpoint where we generate a random. So the service will generate a random comment about cats, right? So let's go back here. So where and then we can also pass inputs like image, text, and vectors, for example, to get predictions out of. And in essence, the web service is essentially a function, right? We're inputting some inputs and getting some outputs. It's just that the environment from which we are passing the inputs could be anything. It could be from the command line, it could be from my Jupyter notebook, and so on. And the function is executed on the server side, and the server side function could be in a different environment, operating system, whatever, right? So that's the distinction, and so you can just think of it as a uh, function abstraction. So what is our objective? So now we're going to switch back to some code. So today we'll just work with sklearn and Flask. Basically, we'll skip these other tools. So 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 these other tools I'll comment on later. So we'll try to deploy an sklearn model, and you'll see that an sklearn model or a Keras based model or a PyTorch based model or even a random forest or XGBoost based model, they all will have very similar way of deploying, okay, on a single server. So and we'll do that right now. And before that, let's talk about another aspect. So our next big task for the session is to deploy a server using a Flask module. Okay, and I'm going to discuss that soon. Before that, let me get back to um, yeah. So let me talk about Flask itself as a way to um, as a template for a web service, a very simple web service. Flask has been there for about 10 years now, or maybe 8 years. I'm not sure. So it's a very simple, pretty popular way to have a web endpoint, to create a web endpoint. Uh, so let's see. Yeah. So the code is given here, but what we're going to do is um, uh, if the link that I gave you had a bunch of notebooks and scripts, so there is a script called echo.py. So if you look at the file, this is a template of a Flask app. Okay, so what you're doing is importing the Flask module, and you're creating an object called app. Okay, from the Flask. Okay, from the Flask class, essentially, and then so we're not going to get into the complications of this detail because this is beyond the scope for us at the moment. So what we care about is, so Flask is a really nice module where what it does is lets you run a server, maybe not a production grade server, and I'm going to comment about it pretty soon. It lets you run a server where it's a server where you can have an IP address and all that, but where the endpoint is mapped to a function. So for example, if you run this uh, if I run this command, so if I run the script on the command line, it's going to start a server. IP address 0, 0, 0, 0 just means just use the IP address. If it has a public IP address, it will use that. Uh, and there's some default port, I think 5000 for this. But at that IP address, it's gonna look for every time I go to that IP address, it's gonna call this function. If I don't give, so I'm going to call this function. Let's understand what this function does first. So it's just setting a initial dictionary data with a single key success and a value false. And then it's looking for parameters that were passed by the request. So if I make a request to this particular service, that request is checking if there is any parameters in that request. If there are no parameters, then it's not do, if parameters is none, then it's just taking a request arguments. Okay, and if there is a message in the keys part of this params object, sorry, I think params is just a dictionary. So, and we can check that pretty soon. If there's a message, then data response is to just echo back the message. So that's why this file is called echo.py. So params would get the message from the message key, the value corresponding to the message key, and dump it into the data dictionary called response, and change the success key field or the value to true, and return a JSONified version of that dictionary. Okay, so it's a dictionary, so you just have to call JSONify to. So, and this is specific to this particular solution. Okay, and that's the return. That's what it returns. So let's actually run this. Okay, so we are in that folder, right? So I don't know if Flask is installed first of all. Let's try Python echo.py conda install Flask because it's not there. Yeah, so param itself is not the so URL slash page, the page one would be this URL root, okay, slash or slash predict or whatever. And I'll tell you what this is as well. So somebody asked this question about what do I mean by params. So we'll actually see what params is. So params is actually, let me, let me do print as well. You can see it. Yeah. So I'm installing Flask and a few other things. and it's so it's running something at this port 5000. Okay, I can't go there because firstly there is no I'm not going to use the browser there. But second uh, thing is that um, that port may not be available. So that I have a firewall configured which only lets 22 port out. So let's see if 5000 is uh, allowed. So how do I do that? Okay, let's cancel this. Um, Actually, I don't want to do this. Let's go here. W status. Yeah, it's only allowing port 22, which is the port for SSH. Okay. Uh, so the difference between params is just a local object that I created, and args is the args I think corresponds to the get object arguments. But if you had a post request, then params would have somewhere else where the post request payload would be available. Okay, so let's actually look at it. Let's debug it. So I'm just going to allow 5000, and let's try that. Copy this. Okay, let's actually do it here. Okay, it will not work first of all, but let me go back here. Okay, so I mean, you guys can actually also access it because it's public, which is not probably a good thing, but you can access this IP address at 5000 and you can see the response. So success is false because I did not give any argument. So it's an echo service. So ideally you should give an argument. Oh no, it's a, let's see what the code says. Um, Yeah, so you need to have a message with the value. So you need to have a payload with message as the key, and um, some value as a payload, which needs to be echoed back. Like for example, hello world, right? So how do we do that? We know how to do that like this. Okay, so this let's copy this, change the IP address. Okay, um, let's comment this out. Okay, so yeah, so this is the argument. So we are doing a get. So Rahul, you asked what's going on. So we made a get request with this key being message and the value being hello from URL, and response from that server was like if you look at the JSON field, its response is just hello from URL and success is true. So now if you go back to the server, yeah, I don't know if other people are accessing it, but so params is none. So if you look at some people access it. Uh, oh yeah. So let's actually go back to the code. So I said print params. So there is no JSON payload is what I'm trying to say. If there is no, so what type of object is params is the question. Um, so params first assigned a value which is flask.request.json, but that is a none object, because a flask.request.json was empty. And so now we are assigning params to this, and this happens to be a dictionary here. Okay, so um, okay, actually, yeah. So that JSON field was none basically, and so we had to take the args, which happens to be an immutable dictionary. So it's a certain variant of dictionary where there's a key and there's a particular value. Okay. So instead of params, you can do. So I think this is because we're handling a get request. You can actually handle a post request in a different way, and there you'll probably have to, depending on how the post request is constructed, you can. This will not be empty. So that's it. So that's echo service. Now, so that's the template, right? So once we know that here's a simple way, a module which can map a query slash. So let's say instead of slash, I want to do slash predict, right? And save it. I mean, generally, I don't think you're supposed to restart, but anyway, I'm restarting. Let's go back here. Yeah. So if you just do this, there was no uh, response because we got, print JSON does not work. So we can do slash predict slash and it should work. Okay, so basically the cool thing about Flask is that it maps a URL on where you can pass on additional arguments to a function. And once you map it to a function, then you know that, okay, within the function, I can just do inference. As in, if I have a trained model and I have loaded it permanently, when I ran this Flask app, I can call here somewhere, load the model. And once I have a model inside the function, I can always do model.predict and return that in the same format. Okay, so that's one way to see how we can just serve a machine learning model as a service. And that's exactly what we do. Okay, yeah. And as I said, you can also, so you guys can actually go to that URL. I don't know this URL. And try it out. Instead of that message, you can use your name if you want. And right now, the reason why, so although we use Flask and we achieved an echo service, it's actually not a good idea to run Flask in production because it's an experimental service. So I think some folks are trying some other messages like temp, cool, and so on. But it's not a production service, and it in fact says that at the beginning. Sorry. Um, Control C. So you can see that this is a development server. So you can actually um, add another application which will call this Python file, therefore the Flask service, and that is going to be more performant. And that's where you can use something like GUnicorn is one, WSGI server, which you can use. But let's not. I mean, you can check that in the notes in the book if you want, and I can also add information about that. Okay, so this is a development server. Now, what we want to do is next. And next part is very interesting. So here you can actually, the same echo service can respond to an image of a cat. So you can send, so now this is where you're sending a different payload. So you're sending a payload, which is a JSON object. So it has a field message, and encoded is just a encoded version of the image. So I don't think we have this image. How do we? Okay, we don't have that image, but that's fine. So we can send an image and we can get response back in image as well. So let's actually see if we can uh, okay, there is no image file here. So does anybody have an image? Okay, let's go back here and go here. Okay, maybe this copy image location. Okay, we got the image. What is it called? Data pipeline. Okay, let's see if it actually works. And what is the URL? No. Was there an additional slash or what happened? Object of type bytes is not JSON serializable. Wait, wasn't the previous image did not encode? There's an error at the encoding. Uh, oh, it's at this results. Really? Object of type bytes is not JSON serialized. Okay, maybe it's not responding. Okay, anyway, I don't know why the image thing failed. I mean, it's something to do with encoding and decoding the image because what we're doing here is encode the image into basically a string, essentially a string or text, and then uh, again encoding the response as that text and trying to go from that to make it an image and so on. So maybe there's some issue with the conversion. So that's okay. Where was I? Yeah. So let's move to a model. Okay. So we want to finish up by serving a model, and here's a very simple model from sklearn. We just call logical regression, and in particular, we are calling. We're going to use pandas, and we're gonna read a file. Okay, and reading a file, as you guys know, you don't have to read a file from disk. You can actually read it from another service. So in this case, I mean not another service, but various sources. And this particular file is at a particular at a particular URL. You can also read from a database and so on. So anyway, from this, we're creating a data frame, dropping the label data frame, label column, and creating the X, which is the input features of the training data. Label column is the dependent variable of the training data, and then you just calling model.fit. Okay, so that's a trained logical regression model. Um, so I don't have a scikit-learn as well on this server. So somebody has please help as a message. Okay. Um, Let me, is Anna on a screen session? Oh yeah, okay. I'll keep running that. Um, Actually what, I think the screen session is not letting me keep the environment, but we'll install that. But this is pretty much a simple model. Um, uh, so once you fit the model, there are two ways you can dump the model to disk. Okay, so scikit-learn models are actually serializable. Serializable just means that they are objects where essentially, like, think of it like a dictionary with keys and values or something like that, or lists. And so these things are easy to write onto disk. Okay, and you can write it onto disk in a particular format. So which is supported by this module called pickle. So you can pickle dump the model. So let me see. So model.fit. We're going to run model.fit. Okay, gateway install. No, not yet. Installing SciPy as well. Okay. Okay. So if we fit the model, and then you can dump the model to disk. You can dump the model using a pickle. Pickle is not just for machine learning models. It can dump any other data files, pandas data frame, or pandas data frame. You know how, to disk, to CSV, and so on. You can do, but general dictionaries, lists, those can be pickled, quite useful. Um, so okay, so sorry. So here we dump the model to disk, and then we're reading the model from disk and predicting for x. Okay, so x is the dimension of x. I mean, uh, I don't know if n dimension is the correct. Okay, okay, let's just see how many rows. Okay, it has 22,000 rows. So you made a prediction on all of them. Okay, so that's fine. So, but one, I guess, one new thing that we want to learn now, I guess I want to point out, is that instead of using pickle, which is specific to your environment, if you want to you want to be able to dump a model onto disk, or maybe an S3 bucket or something like that, dump it, and then you can even email it, or share it on like a GitHub or something. And then somebody else wants to use it in a different environment. Maybe I learned this. I fit this model using Pandas version 1.2 in Python 3.8, and then I have this model, and I have dumped the model onto disk using, let's say, pickle. Then you need you may run into errors because of incorrect packages in the target environment where you want to read the model. Okay, so to fix this and many other aspects, we'll use a tool called MLflow. So MLflow is not just this, but it lets you work with sklearn models, where you'll be able to build a model in an environment which is not the same as in the environment where you want to deploy the model. For example, the model may be built on a Windows system where Pandas is a slightly different version, or the scikit-learn itself is a slightly different version, and so on. Okay, so I don't think I have MLflow either. Instead of trying the command. So for this, it's good to install pip inside the DataSci dev environment. So pip is now going to be specific to, so if I type which pip, this is inside the DataSci dev environment. Okay, so you want to do this because otherwise there's also generally in systems, in these Linux systems, you'll have pip also on the system. So for example, on Mac, there's I think pip and Python 2.7 in the path, so you don't want to mix those things. Let's install MLflow. This has a lot of dependencies, so um, once we install MLflow, all we're doing is the same as this pickle operation. We're just saying, oh, here's a path, maybe model slash logit for this particular, you know, um, uh, games data set, and then uh, save the model there. MLflow.sklearn.save model at that model path. And then you can load the model from that model path, not just here. This is just for demonstration, but you can uh, um, read the model from there. Like somebody else, if you post in a bucket, S3 bucket, but your training environment versions were different from the production environments, it's still okay. So you can they can still load the model without issues. So I don't know if we installed it. Yeah, its dependence includes a lot of things. So, or maybe it was suggested packages, but it installed Docker, it installed Databricks, it installed SQL Alchemy. It also probably Flask, request, auth lib. So it installed a lot of things. So you need to watch out for those things. Okay, so now let's again restart. I don't think the model object will be available. So let's fit the model again. And then same thing. Oh, okay, model slash logic games v1. Okay, models. I'm just creating a directory there. So it saved something in the directory, I mean the model, and it's reading from that path and predicting probabilities over all my training data. So you can see what is in that directory. It's just a uh, some environment information and something called ML model, and then there's a model called model.pickle. So you can look up what this, like the YAML file is this text file, you can see what the information is there, and it probably should be environment information over there. Okay, so that's the model. So now what we can do is skip this cell. Yeah, so now let me open another. Yeah, so it's the same Flask app, but now actually we did not use MLflow here, but we could have used it. So in this script, what the script is doing is to import logic.pickle file, uh, which we don't have, so we'll change this. That's fine. And then once we load the model, so this is the logistic regression model. So you need to have that class, and then you're gonna again, look for arguments. If the arguments are nothing, then if params itself is not none, then you can read the argument values. So there are like 10 arguments here, and then you create a single test instance feature vector, and then you use model.predict proba. Uh, if you want to predict probabilities as well. Um, uh, with this particular test instance, and these additional things are just to pick the response and say that you are able to predict. Okay, so since we don't have this guy, so let's go here and actually maybe let's install import. Comment that out. And this out, not saving the model, loading the model, and calling it model. Okay, you can save this file, and maybe we should just change the root to Reddit. Oh no, let's just get the same. Um, okay, so all we did, so remember all we did change from previous Flask script was just add a load the model before creating the Flask app so that it persists. So that's what I meant by persistence earlier. So model persistence here. Uh, okay, but so instead of basic PyTorch model, we built a basic sklearn model. And saving and loading the model, as said, we can use either pickle. So uh, you can use pickle if you're using an sklearn based model. For PyTorch, for example, PyTorch itself has a if you create a model which extends nm.module, you can actually have a dot save function or something like that. So you can look at the URL here to see how to dump a PyTorch model, for example. And what we saw just now is instead of using pickle for sklearn, for example, you can use MLflow.sklearn. Similarly, for PyTorch, you can use MLflow.pytorch. Essentially dump the model, and that's just to takes care of environment issues. Okay. Now let's go here. Yeah. So the interesting cell is this. So we're gonna make a query, and so for us the query will. So it happens that this particular data set and this model takes a 10-dimensional input and produces a 1-dimensional output. I think it's a yeah, it's logical regression. So it produces it's a binary classification. So it produces a probability, I think, between 0 and 1. So we can check that soon. So let's just change the URL and run that URL, run the Flask app as well. So okay, and if we save it, okay, logic.py. I'm gonna close this one. Okay, it's basically serving the Logit app. Again, it's a development server. Debug mode is off. I can enable debug to show the requests and all that, but that's fine. So the app is running. So if you guys also have this type of, if you open this Jupyter notebook on your local machine, you can also run this with this URL. You get a certain prediction 0.38. You're getting 0.47 and so on. So here we are passing a vector, but you can imagine passing an image and getting back a response, which is, like whether the image is a cat or a dog. And by the way, you don't have to just respond with, so what I showed here is a response where the response is just return a JSONified version of this dictionary. Okay. Instead of that, you can actually have a web page. You can respond with a web page with HTML, CSS, and a beautified version of your response. So you can actually respond back with the original image and with what your label was, if you want. Okay, and even the query that we're doing here, although we are using requests, if you wanted a UI interface, you can have that Flask app when you don't provide anything. Let's say at the slash. If you don't give any parameters, it would open a page where it says upload something, and you can have a button, for example, using Flask forms if you want form submission. and make the request and get back a response. So you can add a UI element, and that's and there are some solutions which add UI element. For example, Plotly's Dash, for example, and there are a few more that let you do that. Um, but that's you can do it once you know this. So so that's it basically in terms of deploying a simple machine learning model. So there's two parts, right? One is you spend a lot of time building a good machine learning model and you want to expose that as an API service. So let's say you worked hard on NLP and you're able to generate nice codes from when users provide prompts, right? That's what I mean. Some of you must have seen this GPT-2 or GPT-3 based services that have come up. GPT is a really good language model, and people have created web services where you can provide a prompt to that model, and that's sent as a request, and the model responds with a sequence of sentences which are quite high quality. So that's the response. So you can actually create such a service, and so this is pretty good. If you want to, for example, also showcase your data science like models or portfolio or something like that. And you don't have to do the hard work of setting up a server, which is what we did to show that DevOps is hard, I guess. You can also use a service like Heroku. Okay, Heroku is a platform as a service. I don't think I have time to go over it uh, today, but with Heroku, you can actually easily deploy a Flask app and not worry so much about like the firewall, like SSH aspects and so on, as long as you have a Heroku account. And of course, there's a vendor, so there's some learning curve involved with working with Heroku to deploy a Flask app, but it's quite standard. It's been there for almost 8 years, 10 years now, so you can use that. So at this point, I guess I'll stop my uh, explanation. Uh, People can access this URL, I guess. We did not provide a message, so it gave us error. I think the app needs to be improved to give a message. So internal service error means, I think, potentially it crashed. No, it did not. Maybe 404. Oh, it crashed because of something. So you can see the uh, issue. So we're not doing input checking here, so there could be issues here. But okay, right now, this I think is not the right way. So there's a different app called Postman. You can try using that to query the service. I don't know if any of you have been able to query this particular service, but that's okay. So yeah, so let's wrap up today's session. So there was a lot of things that we went over, and it seems like I used a lot of commands most of you are not familiar with. Uh, uh, but the objective is of this course is essentially to get exposed to some tools. Okay, we don't need to know, at least the objective is not to have a complete mastery over every tool. For example, setting up a firewall or setting up Conda and all the options of Conda is not the objective. But knowing that Conda is an environment manager as well as packet manager, how Jupyter, you can access Jupyter in various ways. Instead of doing development in Jupyter, you can also do Python development in just text files uh, or IDEs and so on. So these are the things that you should take away from the course, or for example, from this lecture. And today we saw this 30-40 line script is able to serve a machine learning model, an sklearn model. And I'm sure you guys have built or will be building many scikit-learn style models. So this is such an easy way to set up a model and serve the models predictions as an endpoint. So you just have to query with a feature vector. So here the feature vector is like a dictionary with keys and elements. So the first key G1, there is a value corresponding to it, and so on. So if you can pass that as an input, you can generate an output by just calling model.predict probability, right? So with that, let me ask if people have questions, put it on the chat, or you can ask now. No questions? So at any point, was any part confusing that I can just tell you how things are related to each other?
Professor, I have one question. So, like today, we kind of just went through how to set up through Vultr. So, will we be doing this for AWS as well in the next class?
So next class we'll do a model serving via Lambda functions, which are serverless options that are available on AWS. We can do the same. I mean, it's basically on AWS you can spin up the same type of machine. You'll get an IP address. Um, uh, you'll get an IP. The interface will be different, but you'll essentially start very similar machine and you'll get a different IP address, public IP address. So we can do that, but once you get the machine running, inside everything is the same, right? So to get the machine running, I can just show it to you next time when I
Okay,
when I,
yeah.
when I log into AWS. Yeah.
Yeah, that'll be great. Thank you.
So how do we call our model using curl request? So how do you set up a curl request? Um, so you need to pass. Let's see how to make curl requests. Sorry, I'm just checking out the syntax for curl. Um, okay. Mhm. Um, yeah. So in the, for example, in the um, echo service, let me just something like this. Not API login, but okay, let's do that. Let's just double check it works. Um, so my local machine, see message, which is the key, and also, oh, one other thing I forgot about servers is you want to have HTTPS enabled, so you have to go through uh, some Let's Encrypt or something like that to ensure that the uh, that's not on HTTP, which is vulnerable to attacks. Okay. So right now it will not work because that service is not running. Uh, let's see. Nope, that's not the way. Message. Okay, curl get request example. I think we just in this case actually you can just do message. I mean it's the same, but this is not very enlightening. But curl is a very powerful tool. There are many ways to um, you can just do this, but I don't think this is what you're expecting. Let me post that in the chat if you want it. Anyway, that's yeah. So okay, so I think we pretty much completed the class. I'm gonna, so in terms of my to-dos, I'm gonna try to document the commands that I used today. Don't get hung up on the this particular vendor vulture, but AWS is just as fine. Starting a machine is not difficult. So maybe first part of next lecture, I'll just show you how to start a machine. Although we'll do something else on AWS next lecture. If people find what I showed today pretty comfortable, then I would suggest trying out Heroku for sure. Also try out when you try out Heroku, you'll not be able to directly use the Flask Python filename.py or echo.py or something. So you'll have to use a WSGI program like GUnicorn or something like that. So that is an interface between your Flask app, which serves predictions, and the external environment, which from where you get it basically takes the HTTP request and forwards it to the Flask app. So try that out. Um, yeah, and if you have more energy, then today I only showed sklearn. You can try a PyTorch, simple PyTorch model. You can just get a model from PyTorch tutorials, or even a Keras model. You can get a model from just Keras tutorials, because you're not very concerned about the specific model. You're just concerned about how to set it up so as to be able to serve it as a web endpoint, right? So try those things if you want to. Okay. So I'll add the commands right after pretty soon on the web page. And if you have questions, use Slack. For folks who have not used Slack or do not have the invitation to Slack, please reach out to me or the TA. And I think that's it for today. So thanks everyone. I'll see you next week. And so if somebody has questions, you can hang on for a few more minutes and ask me on chat or directly.